Section 5.1 Monomials. Our objectives are to multiply and divide monomials. We're not going to do the second objective there. Now, I gave you this observation sheet, which you should complete first. So I'd take a minute to pause the video and do this on your calculator, and then when you're done, push on pause, and then you can check your answers. So after you do this first set, you notice that when you're multiplying something with the same base here, you can add the exponents together and it will give you the same answer, because you notice this is 243 and this is 243 here, and it happens for every problem that we have up there. So the conclusion is, anytime you have like bases, such in this case a to the n power times a to the m power, you can add the exponents. So that means that a to the n times a to the m would be equal a to the n plus m power. So just to check our understanding, if I have x to the 4th power times x to the 7th power, since they are like bases, that becomes x to the 11th power. Now n to the 12th times n to the 100th, same thing, so that would be n to the 12 plus 100, which would be n to the 112th power. And then for this one, we have like bases with the a, so add the exponents. 5 plus 1 is 6, so that would be a to the 6th. And then notice that we have b and b, so we can add those exponents together. 9 plus 2 gives me 11, so b to the 11th. Now for the second observational set, notice that we are dividing our like bases. So for the first one, 2 to the 7th divided by 2 squared gives us 32, which is the same thing as 2 to the 5th. And when we're doing these, always leave your answers in fraction form. So the conclusion that you should have come up with is, when you're dividing a to the n divided by a to the m power, what you're going to do is you're going to subtract the exponents. So this would be a to the n minus m. So just to check our understanding, if I have x to the 7th divided by x to the 3rd, that's going to be x to the 7 minus 3, which is really equal to x to the 4th power. If I have a to the 900 divided by a to the 378, subtract the exponents, so 900 minus 378 would be a to the 522. And then for the last part, I have my like terms right here, so I'm going to subtract those exponents. So that would be x to the 5 minus 7, and then I'm going to do the same thing with the y's. Y to the 8 minus 3. So when I do this, I end up with x to the negative 2 power times y to the 5th. And we're going to learn in a little bit that we would not leave our answer like this, because really we don't like to have negative exponents. So this is going to change into y to the 5th divided by x squared, and so this will be the correct solution, and we'll talk about that property that moves the exponents to the denominator in just a minute. So if you didn't get any of those, make sure you change and fix your answers. All right, so the first thing we want to talk about is that negative exponent property. If I have a to the negative n power, we don't like to have negative exponents, so this really simplifies. If it's in your numerator, it becomes 1 over a to the n power. And now notice that instead of being a negative n, when we move it to the denominator, it becomes positive. And if I have the reverse of this, then let's say we were given 1 over a to the negative n, so if it was in my denominator first, then I would take this, it would go to my numerator, you flip it, so this would be a to the positive n power, like this. And of course, a cannot be equal to 0 in order for us to do this, because we can't divide by 0. So that's dealing with negative exponents. So monomials is the next part. A monomial is a number a variable or the product of a number and a variable or variables. So for example, a monomial term would be maybe something like the number 12. And then we could also add variables to that. So 12y would be a monomial term. Or it could be a negative number, so negative 5x squared y. I could add more than one variable. And then maybe if I had c divided by 3, because that's really equal to 1/3 c, that would also be a monomial term. So for monomial terms, I know that c over 3 is a monomial, but if we were to do it the opposite way and do 3 divided by c, this would not be a monomial term because there's a variable in the denominator, and monomials are not allowed to have variables in the denominator, nor can they have any variables underneath of a radical. So I'm going to just make a note of that. So no variables in the denominator or under a radical. So that's very important to make sure that you know that. And for monomial terms, also notice that there are no addition or subtraction signs. So I'm going to add that up here. So no addition or subtraction signs, because a monomial term is just one term that you have. So a constant term is the term that contains no variables. So for example, if I had 12x to the 0, there's a note at the bottom of our paper here that anytime you have x to the 0 power, we know that the answer is going to be equal to 1. So for instance, if I have 12x to the 0 power, like we do for example up there, that's really equal to 12 because x to the 0 power is really equal to 1. So 12 times 1 would be 12. Or even if I had just a number, like if I had 143 to the 0 power, I know that's going to be 1. Or if I had y dw all to the 0 power, that would also be equal to 1. And we'll talk about some of those properties in a little bit. So anything without a variable means that's our constant term. Now, the next thing we need to talk about is finding the degree of a monomial term. So to find the degree, you take the sum of its exponents of the variables. So it's the sum of the exponents of the variables. So now if I give you some examples, like let's say we had 2/3 x, notice that there's only one variable here, and when the power is not written, that really means we have a power of 1. So I just had to add 1 with itself, so then the degree would be equal to 1, and again, that's because the exponent is 1. So let's say instead I had some more terms, like for instance 7x squared times y to the 3rd. The degree of this would be equal to, well, notice I have two variables and I have two exponents, 2 and 3, so I add the exponents together, so 2 plus 3 is 5, so the degree of this monomial term would be 5, because we add the exponents 2 plus 3. For the next one, I have -4 for my example. So if I just have -4, remember this is a constant monomial, which means that it doesn't have an x because it's like x times x to the 0 power. So the degree for a constant term would be 0 because there are no exponents. So the next part, if you want to simplify an expression, this is important. So it means to write an expression without parentheses remember, parentheses are like this, so without parentheses or negative exponents. So basically what we're going to do is we're going to add slash subtract, so add or subtract like terms until there's no more operations. Left to do. Now, the next thing we're going to talk about is on the other side of your paper, we're going to talk about the properties of exponents. So some of the properties of exponents are the product of powers when you're multiplying monomials, the quotient of powers when you're dividing monomials, and the properties of powers, which we usually call power of powers. So these are the properties of exponents. Now, it is really important that you understand these properties because we're going to be using them a lot, and we'll also use them throughout the rest of the year. So we've already talked about the product of powers. So when you multiply two things with the same base, you add the exponents together. So we've already said this right here. When you divide two things, that means you're finding the quotient. So the quotient of powers would be when you subtract the exponents. So here you add the exponents, and here we subtract the exponents. And for this next part, the properties of powers, there's a couple of different things. If you have this first one where notice that your a to the n powers in parentheses all to the n, that means you multiply the exponents together. For instance, if I had, let's say, a to the third power on the outside, we had maybe 7. So that would be the same thing as a to the 3 times 7, which would be equal to a to the 21st power. And the next one, if we have multiple things inside my parentheses, like ab to the n power, then that means that everything has to get multiplied. So a to the first power, b to the first power, you multiply that n to both of those. So for example, for this one, if I had, let's say, ab squared, and I want to take it to the third power, I know that a is really to the first power, we just don't usually write it, so a would be a to the 1 times 3 power, and then b would be to the 2 times 3 power, so that's really equal to a to the third, b to the 6th, and that would be my solution. If it's in fraction form, such as the next one, then you are just going to put the power to both of them, so a to the n over b to the n power. And if it's a negative exponent like this next one, then remember we said we don't like negative exponents. So you could switch what's inside your parentheses first, like we did here, and then make it to the positive n power, and then bring in the numbers, b to the n, a to the n. Or if you wanted to, right here, we could do a to the negative n over b to the negative n. Remember, our negative property of exponents, we don't like to have negative exponents. So if it's in your numerator, it would go to your denominator and become a positive exponent. If it's in your denominator, it would then go to your numerator and become a positive exponent. So that's what that would look like there. So make sure you look over those and know them, because we're going to talk about it in more detail in class tomorrow. And also make sure you look over those properties, because they will be important, and we'll do some of these examples tomorrow in class.